Welcome to the Nexus webinar number 2. I'm David Laverty, along with Paul Golden, and this webinar is Designing High-Tech Cannabis Greenhouses. This is number 2 in our series of 6 webinars. And just a few announcements. Please send in questions via chat, and we will answer as many questions as we can at the end of the webinar. So with that said, I'm going to turn it over to Paul to start the webinar.
Thank you, David, and thank you everyone for joining us today. The topic for our webinar today is going to be designing high-tech cannabis greenhouses. And just to kind of start off, I would like to define what we call a high-tech cannabis greenhouse. It's a facility which offers a high level of environmental control, including light levels, photo period, temperature, irrigation, fertilizer, CO2, humidity, air movement, and the list goes on and on. Here we have a couple pictures that are kind of representative of the kind of equipment that we normally see in a high-tech greenhouse. First, the exterior of the greenhouse, we have our fans and cooling system. Then we have an interior shot of this state-of-the-art LED facility growing cannabis. We have a controller, and then we also show some irrigation systems. Some of the things that we're going to present in this second webinar will be what the plant's requirements are, climate control equipment, styles of greenhouse structure, and growing climate considerations for choosing the type of greenhouse you might want. So what all is included in a high-tech greenhouse? Well, our standard Nexus hybrid growing facilities include computer control system, light deprivation equipment, unit heaters for heating the air around the crop, evaporative coolers and exhaust fans, which are the most effective way of cooling and very cost-effective way to cool as well, as you might know from our first webinar. Then dehumidification fans and shutters, intake screening, CO2 generators, and supplemental lighting. And then one of the common things that people choose to put in their greenhouses, depending on climate, are radiant floor systems, or sometimes even under-bench heating. Shade curtains, which help out a lot in very high sunlight environments. Rolling benches, which eliminate the aisleways for optimizing the greenhouse space utilization. And then automated irrigation controllers takes the labor out of going around and hand watering each pot by pot. And then you got your ebb and flood trays and liners. So this is something we can install on top of our rolling bench system for a different style of hydroponic growing, or sometimes even just for soil growing. They'll want to try to capture all the leachate that comes off the plant. Then there's the option for dehumidification systems. This is pretty uncommon for us, but there are certainly people that use dehumidification systems in such greenhouses. Odor control systems that go on the exhaust fans. And then lastly, the irrigation distribution system. And what I mean by this is mostly drip systems.
Paul, I'd like to add that what clients are doing here is designing a customized growing system, because the climates of Arizona are very different from South Florida in terms of moisture, with the dry climates in Arizona and the high humidity in Florida. So this gives you some options to be able to design a greenhouse that's customized for your geographic location.
And so one of the things the greenhouses do is they provide plants what they want. Plants want water, they want air, they want nutrients, they want the right temperature, and they want sunlight. And greenhouses are designed to optimize all the plant's wants. First, going into water, water can be delivered to plants in a number of different ways. Several growers that we know are using high-tech systems. Some are still hand watering. But high-tech irrigation systems have been around for years. They've been mastered. And for the most part, they're very reliable. So what we show here in these different diagrams is first on the top left corner, we show a bench system, a rolling bench system, which of course you can't see the bench too well, but you do see the manifolds, the yellow hoses that go up to the irrigation distribution. This is a system that uses drip irrigation with soluble fertilizers, and it doses the plants with the exact amount of nutrients that they're looking for at just the right pH. The image just to the right of this bench system is a representative of the dosing systems that are used to provide these nutrients and the fertigation. So these are a number of automatic dosers that pull from a different set of reservoirs for NPK as well as they might pull from an acid vat to adjust the pH down to the ideal, let's say, for example, 6.0 pH they're looking for in the water. This system measures the total dissolved solids, the parts per million of salt, the DO, the dissolved oxygen level, and the pH. It also has a filter for keeping any of your inline injectors from being clogged, and it has a backflush for getting out any debris that might be inside that filter. The bottom picture shows a hemp farmer, a CBD farmer that's raising larger plants in a very large fabric pot, and he uses drip hose to provide the amount of water that he needs for those large pots, and that's all automated. And then there's a rendering of a high-tech system, which is oftentimes used in traditional horticulture, say, for example, a tomato or a cucumber grower who is monitoring the nutrients to a pretty high degree of precision. And this computer-controlled system has real-time, forward-thinking adjustments to the dosing of the pH and the dosing of the different nutrients to match the plant's needs at a specific stage of their production. And these kind of systems are a little bit more fancy than what we see in practice with the cannabis guys, but there certainly are people using them. And so I'd like to just kind of note that there's different options here for irrigation. There's drip irrigation, there's ebb and flood, and then there's also people that raise in troughs where water runs from one end of the trough to the other, kind of similar to an NFT guider system. Next, moving on, in terms of the plant's wants, we have air. And of course, everyone realizes that plants absorb carbon dioxide and produce oxygen. Most people probably don't realize that the opposite is true during the nighttime hours. When plants blackout, they absorb oxygen and produce CO2. But most folks have, who are growing either have already learned that CO2 is very important for plant growth, and it can be easily depleted in a sealed up environment if you don't supplement your CO2 or allow outside air exchanges. So there's two different ways of bringing CO2 back into your grow environment. One of them is just by letting outside air mix in, and the other one would be to either burn natural gas or inject CO2 into the system. This is a picture of a Johnson CO2 burner, which is pretty standard in the industry for greenhouses. This burner can run off of natural gas or propane, and it produces CO2, but it produces it very cleanly without any carbon monoxide, so workers can be working inside the greenhouse while generating CO2. Most commonly, these systems are being used in the winter months when the greenhouse is sealed up tight to keep heat inside the greenhouse, and there's no air exchange with outside air to replenish the depleted CO2 levels from the plants. However, these systems are used in the summertime too, just not during the times of the day where you're in full exhaust. Most often they'll use this system in the morning hours before the greenhouse is heated up to the point where the exhaust fans get turned on. So they'll run these CO2 generators for the first few hours of the day and then turn them off later on in the day.
And what these tools are allowing you to do is to experiment with different growing conditions so that you can create the ideal atmosphere for the plant, at the same time always focusing on an optimal amount of production as well as minimizing your costs.
The next thing to consider when talking about air is the humidity level in the greenhouse. Humidity in the greenhouse is carefully monitored by maintaining and pulsing, which is what we call when we open up the vents and we heat the greenhouse simultaneously to properly mix the air from the outside, which might be lower humidity, with the air from the inside. The humidity impacts both water loss, leaf temperature, nutrient uptake, because if you think about the ability for a plant to transpire is also the ability for a plant to pump nutrients from its roots up through the plant, and then eventually water leaves, but nutrient stays behind inside the plant's cells. And then lastly, if the humidity levels are too high, or sometimes in cases too low, leaf disease can take place. And that can take place in the form of bud rot or powdery mildew. And so managing humidity is a pretty important topic when you're discussing any type of grow, whether it's greenhouse or warehouse. So as I said, greenhouses maintain the humidity by pulsing in cool outdoor air and then heating it up inside the greenhouse structure. So here's an example. if you were out in, let's say, for example, Seattle on a summer rainy day at about 55 degrees outside, if it was 100% relative humidity and raining, if you were to slowly bring in some of that air from outside, heat it up to 75 degrees, the growing temperature that you probably want your plants to be at, that air already by the process of just heating it up, it has been reduced to 50% relative humidity, and there was no additional equipment needed to dehumidify. In very rare occasions, we need additional dehumidification equipment in climates that might be very hot and humid. But for the most part, the humidity levels outside the greenhouse are highest during the cold hours of the day, and we're able to bring in that cold outdoor air very slowly so we don't shock the plants, heat it up, and reduce its humidity just because hotter air can hold more water, and so the humidity goes down. Moving on, now we're going to talk a little bit about the temperature requirements for cannabis. Cannabis prefers to be grown between 75 and 80 degrees. It's kind of a tropical plant. The average daily temperature of the plant controls the speed of the growth. So if it's, it could be very hot during the daytime, but very cold at nighttime, and the growth might not really be all that great because the average daily temperature was too low. Low temperatures obviously cause chilling injury. That's one of the reasons why people choose to go into greenhouses, from outdoor growing, because they can't get a long enough season outdoors to produce a successful crop. Excessive high temperatures stop growth. The same is true about low temperatures too, but more so for high temperatures, it tends to stop the growth. It doesn't necessarily damage the plant in every case, but it does slow down the growth. And then temperature differential can be used to control growth habit. So temperature is very important for plant production. And greenhouses do a really good job of keeping temperatures within the desirable zone for the crop. They use evaporative pad cooling systems, as you see in the picture down below, to effectively reduce the temperature below what the outside temperature would be during the times of the year where it's really hot outside. And this system, if you remember from our first webinar series, this is a very cost-effective system. It's about 1/10 of what it would be to HVAC a similar size area in terms of its energy use. So this picture here in this diagram of this pad wall system is what the intake side of the greenhouse looks like, where the air comes into the greenhouse. Now the exhaust side looks a little similar to this, where you have the center picture here, where you have exhaust fans on the gable wall or one of your exterior walls, and those fans, like you see in the last same picture, there's a very high efficiency fans. They take very little energy, less than the power to run one HPS light bulb to cool a giant zone. And one of the things that Nexus does that other greenhouse manufacturers don't always do is we supply breathable walls, blackout walls over our fans to keep the light from coming in so growers can cool during the blackout hours of their greenhouse. So these breathable walls are shown in the right-hand side picture, and you can kind of see it's a plastic material with a number of corrugates in it, a number of curves in it, and the air can move through those curves, but the light can't take a bend, and so it gets absorbed inside that plastic, and there's no light seen from the inside when these fan shutters are open and the fans are cooling during blackout. Moving on, so we talked about cooling, now let's talk about heating. So heating can be done in a number of different ways in the greenhouse environment. It can be done through unit heaters, which heat the air, and that's a very effective way of heating. These are pretty high efficiency, about 80% efficiency, low cost piece of equipment in terms of hardware to install. They're very resilient. Almost in every case that we build for our hybrid facilities, we have a redundancy built in. So a large zone might have 2 unit heaters where it's only going to run the second unit heater a few hours a year. It's more of a backup system for the coldest hours of the year, but it's more of a backup system for if the other one should ever go out, because you wouldn't want your crop to freeze on a cold winter night. And so they're very good for redundancy. And then there's another option, which is using radiant heat. Radiant heat comes in a couple different forms. One form is underbench fin tube heating, which is also called hydronic underbench heating, which you can see in the right-hand picture. This kind of heating is very popular for growing young plants because it provides heat to the root zone, and it helps jumpstart the young plants by getting their roots going. Typically speaking, we don't heat 100% with hydronic heating, so we oftentimes still use a unit heater so that we don't overheat the roots on a very cold night and dry out the root ball. And then hydronic heating, in terms of pin tube heating under bench heating, creates a nice natural convection inside the greenhouse where the heat rises up underneath the plant canopy and kind of keeps air moving around and dries the floor, dries the leaves, and kind of reduces a lot of the scare for disease. This system's powered by giant boilers, which are very high efficiency, and they can also supply heat to in slab. So if you want to grow on the ground, you can grow your pot straight on the ground and have the slab heating, and it works pretty similar. Although the slab is not as good of a conductor of heat as the aluminum thin tube that's used underneath the tables.
Well, I'd just like to add that with unit heaters, many of our clients look at this as a core component for heating. That's the basic heating element that you have in a greenhouse. With the underbench heating or the radiant floor heating, that's a supplemental option in order to provide additional heat at the root zone. Many clients find that this method of heating gives extra plant growth when they're really focused on plant output.
And that's true. And this kind of loops back to what you said earlier in the day, David. Your choice of equipment is really going to be dependent on the type of climate that you're in. Most folks probably won't install a radiant heat system in a warm climate where it's not being used very many hours of the year. But if you're in a cold climate, you're going to want to probably install a high efficiency heating system because it's going to be running all the time, more or less. And then next, I'd like to talk a little bit about the sunlight and how the plant responds to sunlight and how we manage sunlight in the greenhouse environment. So before talking about how lighting is managed in the greenhouse environment, we have to kind of define what the terms are. So when talking about lighting, there's three different aspects that are important to note, and they all mean different things. First, there's the light quantity. Light quantity refers to how much light is hitting the plant. It can be measured in terms of ppfd, that's the photon flux density, or it can be measured in terms of DLI, the daylight integral. And I'll define this in a later period here. Then there's the light duration, which is managed by our light deprivation system. This is how we manage our 12-12 photoperiod in flower or our 18-6 photoperiod in veg. And then lastly, there's the light quality, and this kind of refers to the spectrum of light, whether it's more red or more blue, full spectrum, or if it's infrared or if it's ultraviolet. A properly designed greenhouse will maximize the usable sunlight and supplement only as needed to save you costs. So some of these terms might be new to folks. I'm going to first start by describing the instantaneous light level, which is how much light hits a surface at any given moment. So you can kind of think about this as the amount of rain that hit the surface, and this is measured in the ppfd, which is a unit of micromoles per meter squared per second. So if the ppfd is the amount of rain, the daylight integral would be the amount of rain that's accumulated inside the rain gauge. If you had a bucket outside catching it all and accumulating over the course of the day, this over time, these little particles of light would accumulate, and there would be millions and millions and millions of them, and now you would measure it in a different unit, and that unit would be moles per meter squared per day. And so just as a point of reference, the daylight integral that the cannabis crop most often prefers, depending on strain, would be somewhere between 35 and 40 moles per meter squared per day. And that's, it's kind of hard to achieve in a warehouse environment. It's pretty easy to achieve in a greenhouse environment. In most places around the world, you'll kind of hit that in the summer months just without any supplemental lighting at all. And then if you wanted to talk about the amount of light that the plant's receiving at any given instant, the plants maximize somewhere between 800 and 1,000 micromoles per meter squared per second. And I think we have a better diagram to show you that. So in this slide, we show the plant's response as a result from how much light the plant's receiving. So goes back to the old adage, the more watts of light that a plant receives, or the more micromoles of light the plant receives, the higher the yield will be. And so we have two lines here. We have a red line and we have a green line. And the green line shows a photon flux density, or PPFP, somewhere right around 700 micromoles per meter squared per second. That's how much rain is hitting, or how much light particles is hitting that plant leaf at any given moment. And you can see that that's about 90% of where the plant's maximum production would be. But in the greenhouse environment, where we have free light that can easily reach 1,000 micromoles per meter squared per second, we get an extra 10% of production out of that plant just by being in a high light environment. And that's, if you do the math, 1,000 micromoles per meter squared per second is about 40 moles per meter squared per day DLI. One of the most important of the three areas for cannabis production is photoperiod. So typically speaking, growers are using a 12-12 light cycle of flower to force the plant into thinking it's the end of the season and it needs to go into flower reproductive mode. And then during the vegetative state, they want to have long daylight hours to get the plant as large as it can possibly be and kind of slow it up. That area is going to be having a 18-6 photoperiod. So the greenhouse equipment can control the day length to provide a constant year-round production. So you're able to get your 5 cycles per plant spot per year out of your greenhouses. So this little diagram down below is kind of representative of what a cannabis greenhouse might look like in its most simplistic form. We have one house off to the left, which is a veg house, and it has its own light deprivation system, or maybe it doesn't. Maybe it just has supplemental lighting that allows it to get an 18-hour photo period, 18-hour light period, 6 hours of dark. And then your other two houses next door would be a flowering zone, and that zone is one giant zone, which is every plant inside that zone receives 12 hours of sunlight and 12 hours of dark. So it wouldn't really matter whether you're week 1 of flower or you're week 10 of flower. As long as they're in flower, they're all in that house and they all get the same photo. Then lastly, we got the spectrum. And the spectrum of light is important because the plant doesn't use all wavelengths of light that's produced by the sun. It really just cares about the PAR spectrum, which is the photosynthetically active radiation part of the spectrum, anywhere between 400 and 700 nanometers. And you can see here that's just a very narrow band. And so what we try to do with our greenhouse covering is we try to transmit as much of that PAR spectrum into the structure while minimizing any additional light outside that spectrum that just goes towards heat gain in the structure, because most often you don't want that additional heat gain heating up your greenhouse. One of the ways we do this is by using state-of-the-art covering. Most of our cannabis greenhouses use a polycarbonate covering, and almost everyone's using a diffuse covering these days, which takes the direct light, which you can see in this diagram to the right-hand side here. It takes the direct light, just enters it on the greenhouse covering, and it shatters it so that it's able to bounce around inside the greenhouse, get deep inside that plant canopy, and allow light to penetrate down to the lower buds and make those more productive, so you get less larvae.
Well, one thing I'd like to add here is that with our designs, we have metal sidewalls, and the metal sidewalls help out with light deprivation. So you'll lose a little bit of light from the metal sidewalls, but you gain the light back through the diffused polycarbonate roof coverings that diffuse the light and distribute it throughout the plant canopy.
And one thing about these coverings too, they reflect out the infrared light during the daytime hours, and they reflect it back in during the nighttime hours. So for those of you that aren't familiar with infrared light, that's basically heat. And so you're trying not to overheat your greenhouses during the daytime. You'll still receive heat from the PAR light, the light that the plant's actually looking for, but you're bouncing out the light that the plant doesn't want. And then at nighttime, instead of having your greenhouse radiate out a bunch of heat in the form of infrared radiation, these covers actually keep that heat back into the greenhouse. And then we have, in addition to the greenhouse roof covering, we have the light deprivation curtains, which act as a giant blanket at nighttime to keep the heat in. And so here's kind of a diagram, a couple pictures showing the different curtain systems that we use. If the light levels are too high, we'll use a shade curtain system. So say, for example, we're building out in the desert, we'll use a shade curtain system like this to reduce the light during the peak heat of the summer and kind of reduce the heat inside that greenhouse structure. So that's shown off on the left-hand side of the picture of this slide here. It's all automated based off of how much sunlight's coming into the greenhouse and being picked up by the light sensor. And then to the right-hand side, we have a picture of our light deprivation system, which closes up and completely blocks out light. And so people are going to obviously ask, what about supplemental lighting? And not everyone needs to use supplemental lighting, but it certainly does help. And so supplemental lighting is controlled by the greenhouse controller. It's used to kind of even out your DLI. You know, in the wintertime, you're going to have less sunlight. So if you don't supplemental lighting, you probably have less yields. But in the summertime, you're probably not going to need sunlight. You're not probably going to need supplemental lighting at all because the sunlight's sufficient. So the greenhouse controller is able to monitor this. That's one of the benefits of having a high-tech greenhouse. And we use a light sensor, which is shown down there in the bottom picture, to pick up light inside the greenhouse and then turn on and off the supplemental lighting as needed to give you your ideal PPFD, which is your instantaneous light level.
I'd like to add here, Paul, that there's many spacing options that can happen with lighting. We prefer to have one light every 50 square feet, but that can also range from 36 to 72. So there's different variety of options depending upon your geography, your budget, and how much supplemental lighting you're going to need.
And the lighting equipment you're going to use too. LEDs are going to vary a little bit from HPS. HPS are really the workhorses, and they produce a lot of light, so they can get you can really spread them out over a large area, like David said. 50 to 72 square feet per lamp is not uncommon. If you're going to be using LEDs, most LED manufacturers don't have the power yet to match the HPS light levels, so you'll probably have them a little bit denser. So yeah, that's certainly true. And the best way to control your costs when running these systems is really to have a good control, integrated control system for the greenhouse. It's really the brains or the dashboard of the greenhouse, and that's what really makes a high-tech greenhouse. Without the control, you have all the equipment that you can't run with it. So here's an example of some crops that are being produced in these high-tech hybrid Nexus greenhouses, and you can see these plants are receiving the ideal conditions 24 hours a day, 7 days a week, regardless of what's taking place outside the greenhouse. It could be snowing, or it could be scorching hot in the desert, but they're getting all the wants that they're looking for. That's important. We're going to switch gears a little bit. It's important to talk a little bit about the climate and some of the conditions that you have to consider when you're designing your greenhouse grow. And this is really where we prevail as a team here at Nexus. We help our customers get through some of this misunderstanding of what they're going to need. So we supply a number of different greenhouse structures that can be applied in a number of different climates. There's certain structures that work out better in some climates than others. And so if you're in a very dry, windy climate, we have the structure off to, and hot, like a desert, for example, we have the structure off to the left-hand side, which is designed for maximum cooling. It uses mechanical cooling. And then if you're in a in a kind of a structure, the environment that doesn't have that much light, we can supply clear sidewalls instead of our metal sidewalls. They're not as secure, but we can supply it so you can do it. And so it's just a matter of whether you're allowed to do that in your growing environment or not. And that's kind of represented in that center drawing on the top there. If you're in a very, very cold climate where you have to worry about snow loads, well, you need a very well-engineered structure. The A-frame style greenhouse of our Nexus Bale, which is most common for our hybrid facilities, is very popular. It's a very strong structure and it's very versatile. And then if you're in a climate that's ideal for growing, and it doesn't really need much protection, the crop doesn't need much protection because you have a long growing season and you have the right kind of temperatures, then you can choose to do a passive structure like the one in the center bottom, where you can have roll-up sidewalls, which can still be light depth, and you can have roof vents, which create nice homogeneous climate inside the greenhouse. I will, however, note though, you look at the structure and we still have exhaust fans because it's very challenging to light depth and cool simultaneously in a passive house. And so we're going to talk a little bit about that next. So the question we always come up against is, should I build a passive greenhouse or should I build a mechanically cooled greenhouse? And, people have probably seen a number of different greenhouses out there. If you're not familiar with the cannabis industry, everyone's at least seen, nursery centers and garden centers with high tunnels and ground-to-ground structures that are passive. They're a very low-cost approach, and that's probably not what we're talking about when we're talking about high-tech greenhouses today. A passive greenhouse, it can be a very good structure in the right kind of environment. Say, for example, Northern California, where your days are pretty warm, you're never that hot, never that cold. There's plenty of places around the country that have these niche climates, but not everywhere. And in fact, most people won't have that niche climate. So some of the pros of a passively cooled greenhouse is, first of all, you don't have any cooling costs, which is great. You can just roll up the sidewalls, open up a vent, and you don't have to worry about that greenhouse overheating, and you don't have to worry about paying for energy to cool it. They're fail-safe, so should the power go out, should you be off-grid or something of that nature, you have the walls rolled up, and whatever the outside temperature is, it's probably only going to be a few degrees hotter inside the greenhouse if it's designed properly. Even humidity levels, that's true. Whatever the outdoor humidity is, though, that's going to be your indoor humidity. So if it's raining outside, it's going to be pretty humid inside. That's true of a passive greenhouse. Some of the cons are they're not as secure. So, of course, if you have roll-up sidewalls, somebody can walk right in that sidewall if they wanted to. They're nearly impossible to odor mitigate. So here you have all of these open walls and open vents that you just can't simply try to block the odors from escaping when the wind blows. They're a challenge to insect screen and cool properly. So you can certainly insect screen them, but it takes a lot of vents to get the amount of air that you need to move through the insect screen to cool it properly. Just think about your screen door in your house. If you have your front door wide open in your house, and the front screen door wide open, that is, the air is blowing right through the house. If you close the screen door, sure, it's still cooling the house, but it's greatly reduced the amount of wind that moves through the house.
Well, I'd like to add here that a passive greenhouse will work fine in many of the arid areas of the West where you don't have the high humidity. But for those growers east of the Mississippi River, the southeast, the Great Lakes, the northeast, they're going to want to focus more on a mechanically cooled structure.
That's correct. And the other thing to note too is if you're in a very hot climate, the passive greenhouses won't cool below the outdoor ambient temperatures. So that's if you're going to be in a climate that's reaching 100 degrees pretty regularly in the summertime, you're inside your structure. You're going to be 100 plus degrees inside there. And then the last thing I want to kind of say is they don't perform too well in blackout conditions. If you're 100% passive, you can't expect to cool when you have all your blackout curtains closed and your sidewall curtains closed, and there's no mechanical cooling. That's why, for example, in this top structure, in this top picture, we have fans for when the roof vent's closed and when the blackout curtain overhead is closed and when the side roll-down curtains are closed. We could still pull air from one side of the structure through a light trap and then out the other side of the structure and keep it pretty dark inside that structure. So let's move on to mechanically cooled greenhouses. So mechanically cooled greenhouses, they could either use evaporative coolers or not, but they'll always use exhaust fans. A couple of the pros here is they're very low cost for operation. Remember, as I said earlier, these exhaust fans take less power than one of your HPS flights, and they cool a massive amount of area per fan. You can cool up to 30 degrees below outdoor ambient temperatures, just depending on which climate you're in. On the more humid days, you're not going to cool that much. If you're in a really dry southwest climate, or say, for example, Colorado, Arizona, California, you could probably get pretty close to 25, 30 degrees of cooling on a very dry, high heat day where the humidity is pretty low. These systems have the tightest temperature control because the computer control turns on and off these fans based off of need. And so they're pretty much dialed into almost the degree that you're looking for if the thing is designed properly. They're easy to odor mitigate. You can see here in the bottom picture all these exhaust fans on our houses, and they have little rings on top of them, and on top of the housing. You can barely see it. Those rings are the odor mitigation rings. They spray out an aerosol, and because all the air for the greenhouse comes out through those fans, any escaping odor would be at those fans. And so this aerosol automatically sprays out when the fans turn on, and it would neutralize any odors that were being sprayed out into the environment. They're very easy to insect screen. So let's take a picture. Let's take a look at the rendering up above. You can see where the red arrows are. That's the intake of the greenhouse where the air comes in. It goes into a corridor, which is kind of it's a 12-foot wide section where the air is, it's heated up if it's cold. That way it doesn't come into the greenhouse cold. Or if it's warm outside, it's fine. It goes into a pad wall system, and that pad wall is going to cool the greenhouse. That evaporative pad cooling system is going to cool the air going through it. It's going to move evenly across the greenhouse and then be exhausted out through the exhaust fans. And that's one thing about mechanically cooled systems is that they tend not to be too stagnant on the inside of the greenhouse when the fans are running. They've got good air mixing, and then we also include a number of mixing fans inside the greenhouses to circulate air, even for when the exhaust fans are not running. Say, for example, it's a cold night and you have your blackout system closed. We run mixing fans inside the greenhouses to reduce humidity and manage any kind of temperature fluctuations. And we'll get into a whole other webinar in a couple of episodes from now where we talk about greenhouse operations, and we'll get into these pieces of equipment in greater detail. So if you're looking at the cons, some people might say, what are the cons of a mechanically cooled system? Well, in my opinion, there's really not too many cons. I think the mechanically cooled system is a way to go for a cannabis production facility, especially if you have to worry about odor mitigation, especially if you have to worry about insect pressure. The one thing you will have to do is you'll probably have to have a backup generator, because if you're in summertime conditions and the power grid goes down, those greenhouses are going to overheat without a backup generator. But most folks that are planning a greenhouse cultivation facility for cannabis, they're going to have a backup generator one way or the other, just because of the value of the crop. And then the pad cooling system does add humidity. Not that you have to have a pad cooling system to be mechanically cooled, and not that humidity is a bad thing, because sometimes in the high heat of the summer in a very dry climate, you might want to add that humidity back into it. And certainly you're going to want to use your pad cooling system on a very hot day, even if you are in a high humidity environment. So just as a summary, some of the benefits of a high-tech greenhouse is they provide the crop that you're growing with all of its wants: water, air, nutrient, and sunlight control. Construction needs to be based on the growing environment that you're placing it into, basically the type of climate that you're placing it into. You have to think about what kind of snow load you have, what kind of wind load you have, and also whether it's very hot in the summer and very cold in the winter, so you need a very versatile structure, or if it's just a very moderate climate, then you can have a structure that's more passive. Passive is great, but most growers require a mechanically cooled system. If not for odor mitigation, they need certainly some insect screening to maintain, let's say, for example, their organic standards, or they just want to have low pest pressure inside the structure. And then lastly, the greenhouses are versatile in almost every climate. So they're not cool in almost every climate, and they're versatile and you can install them just about anywhere and have better, in my opinion, better production than you would have in a warehouse environment.
Okay, if you have any questions, we're going to be addressing questions next. So hopefully you've been able to send some in via chat, or if you can send one in over the next couple of minutes, that would be great. For additional information on our webinars, be sure to go to our website at nexuscan.com. Click on the webinar box in the lower right-hand corner. You can see podcasts of our previous webinars. You can also sign up for new ones. You can give us a call at 720-330-0830 if you have any questions, if you want to talk with a sales manager, or follow up on any topics that you've heard here. And just a little bit about Nexus. We're celebrating 50 years of U.S. manufacturing this year, so this is an exciting milestone for us. Our cannabis projects have been completed in 12 states, and we have over 1 million square feet of cannabis projects completed. Just a couple of new items. This webinar will also take place on Thursday, May 18th at 1 p.m. Eastern Time. So if somebody you know wants to hear this again, they can tune in at that time as well. The third webinar in our series will focus on budgeting, putting together a budget for your project, and we will focus more on a business perspective to give you some good business information to keep in mind. So thank you for joining us. We appreciate it, and we hope to hear from you if you have any questions